Hi, to start today, I'd like you to, there's going to be four quadratics coming up, and I'd like you to write them in completed square form. We've got four options here, just to give you a bit of guidance, but try not to look at them. Try to complete the square and then go for your answer. Okay, I'm just going to leave a little bit of a break in between each one, so pause the video and then play it and so on. So, we know that we basically divide that number 4 by 2, and put it in a bracket like this, x plus 2 all squared, we're then going to need to minus 4 and add 10. As a result, it's going to be plus 6. It's going to be this one here. This is what you should be doing. Do show your work and don't just sort of guess the answer. Yes, we can eliminate A and B really quickly because we know that we have the 4, but be careful. Next one. This time we're going to have the 6. We're going to minus 9 and add 1. So it's going to be A. Here, bringing in a negative. We do it exactly the same way. We have the minus 4 this time, and we're going to still minus 4, because that's what minus 2 all squared is. Don't worry that there's a minus, just treat it like this. Minus 10. This time it's going to become more negative, so it's going to be A again. And finally, how about this one? So we can still complete the square when even if 2 doesn't go into the number. It's going to be x minus 5 over 2, or 2.5 in this case, squared. And then we're going to need to minus 2.5 squared. Actually, 25 squared is 625. That is worth trying to learn. So this is going to be, I'm going to minus 6.25 in a similar sort of way, plus 3, so it's going to be minus 3.25. The answer is going to be B. Okay, hopefully you're happy with that, and you could find the turning point of any of these completed square forms if I asked you to. Let's just pick this one here. What is the turning point? So hopefully you've thought about it. Well, the minimum is going to be minus 6, and it's going to be when x is 2. And the similar goes for all the other ones. Today we are going to continue with completing the square. We're not done. We've seen that we can write any quadratic in the form x squared plus bx plus c as x plus p all squared plus q. We actually even worked out what p and q would be for this this more general case. Here's an example. I mean, you've just done some, so you can write x squared plus 4x plus 10 in this form. But what if we have something like this? Suddenly, there's a 2 in front, and we still have to be able to deal with it. Actually, the good news is there's just one extra step, really. I mean, maybe it turns into a few more than one, but one essential extra step. We can actually write it, oh, here's the clue really. We can write it in completed square form like this. We're going to take the A outside the bracket essentially when we write it in completed square form. Let me show you an example, and the turning points are still going to work in the same kind of way, so we're going to keep going with those. Right, here goes. So when I get 2x squared minus 8x plus 1, the first thing we should do is factorize out the 2. Now I can't factorize out the 2 easily from 1, and actually here's what we should do. You can factorize, you could write a half inside the bracket, but if you notice in completed square form, we've always got the constant at the end by itself. It's absolutely fine to ignore it and just put it as plus 1 like that. And now what we've done actually is turn it into something from last lesson. Just worry about this bit here, completing the square on that. So we're still going to get 2. Now I'm going to do different kinds of brackets now because I'm going to get brackets inside brackets. So I'm going to have my square bracket, and then I'm going to complete the square on x squared minus 4x. So that's going to be x minus 2 all squared. That's going to give me the x squared minus 4x, but then I need to minus 4 as a consequence. And then I'm going to put my closed bracket in. Okay, and I've actually completed the square on x squared minus 4x. Just this one extra step of taking 2 out first. I've not worried about the 1. If I had worried about the 1, what I would do now is multiply back through, and it wouldn't really matter. It's just making more work for myself. I can actually now multiply back out by the 2 to get it in completed square form. You can see that just on the top right is how we want it. We're not quite there. So it's going to be 2 lots of x minus 2 all squared. And then I need to do 2 times minus 4. So it's going to be minus 8 plus 1. Let me just tidy up that x. And we're basically there. 2x minus 2 squared minus 7. We've got it in completed square form. This is brilliant because the turning points can now be seen again. Just because there's a 2 there, it makes no difference. This thing is still always going to be greater or equal to 0. And it can equal 0 when x is 2. So the turning point is going to be 2 minus 7. We're done. Try this one yourself. Pause the video, give it a go. Do try it. Look at my steps on the left. Give it your best shot. If you get stuck at some point, then replay the video. But if you can get there yourself, then you've understood the main idea of today's lesson. Here goes then. This time we're going to factorize out of 3. At the moment, it goes into the x really nicely. We're going to get x squared plus 4x. And I'm still going to just put the plus 10 after the bracket. Now I'm going to introduce a square bracket, and I'm going to again complete the square on this thing here. So it's going to become x plus 2 all squared, and then I'm going to be minusing 4 plus 10. Now expand it back out. Let me just rewrite that, it looks a bit messy. Final step, just bring the like terms together, so it's going to be minus 2. And we have completed the square. The turning point is going to be minus 2 minus 2. Well done if you got that. If not, does my explanation make sense? I hope so. Obviously, it all relies on being able to complete the square from a previous lesson. You've got to make sure we do the extra step and then follow through on completing the square. Right, second kind of example. If you're feeling confident, then by all means, give this a go. Otherwise, I'm going to explain how we deal with it. So if you've had a go, brilliant. If you're not sure, here's how we can do it. First of all, put it in the form we always have for quadratics. Minus x squared plus 2x minus 4. Now this time I don't have a number like 2 in front of it, but I do have a number in front of it, and that number is minus 1. It's still a slightly different case from last lesson. And what we should do is actually factorize out the minus, just like we did really when we were factorizing quadratics. But in this case, it's going to become x squared minus 2x, and we're going to leave the minus 4 there. Again, I've got it in completed square form. So it's going to become minus, then I'll put a square bracket in, x minus 1 squared minus 1. So I'm doing this quite quickly now because we've done it a lot already. Minus 4, expand it back out, plus 1 minus 4. Be careful, you've got a double negative, so you've got to plus 1, and we get minus x minus 1 squared minus 3. Now this is the first one that I've done completed square form on where it's actually a sad quadratic. It's going to be one of these. So it's going to be a maximum. This thing is always less than or equal to 0. It's still a turning point. I'm just pointing out that it is a maximum. So the maximum is going to be still when this thing is equal to 0, when x is 1, and then the maximum is going to be -3. So after that, it's always going to be less than -3 actually. This is, you can't get above -3 with this quadratic. Try the second one yourselves. And by the way, well done if you got that, or at least even if you gave it a go, you didn't quite get there. So this next one I'm going to deal with in exactly the same way. Write it out like this first. Factorize the minus out. Just turn it into something that we know how to deal with. You don't have to use a square bracket. I should add, it's just if you start adding lots of brackets and you don't know which goes with which, whereas when I use different kinds of brackets, it's clear. Okay, remember, just because it's a negative, it's still -9. We're basically minusing -3 all squared. And I left my answer there, but because this is positive, you might write it with the positive. This is arguably more simplified with the number like so. It's absolutely fine if you leave it as minus x minus 3 in a bracket squared plus 15, but this is, you might see it sometimes written like this. And then we get the turning point. It's again a sad quadratic. The turning point is going to be when x is 3, and we're going to get a maximum of 15. Then it's always going to be less than that because it's another sad quadratic. Whew, hopefully you're in a good place here and you tried that one and you're getting there, you're understanding it. Right, let's keep going. These are going to be slightly more awkward, but still follow through on the method we've been given. You're just going to get some fractions going on. Okay, so I'm going to have to take 3 out. There's nothing I can do. It doesn't go into 8, so that's what makes this just a little bit more awkward. Is it trickier? I don't know if tricky is the right word. So I'm going to get 8 over 3x. I'm going to write it as 8 over 3x. You might write it as 8x over 3. I like to get the fraction there. And I'm not going to take the -3. I'm just going to leave that here. Right. Same again. Complete the square on this. It's just fractions going on. So I'm going to have 8 over 3, which you either write as 8 over 6 and then simplify to 4 over 3, or you just have the 8 essentially. You can just write 4 over 3. 4 over 3 plus 4 over 3 is 8 over 3. I know I've got negatives going on, but it's the same idea. And I'm going to have to minus 4 over 3 squared. Close the bracket. Not quite got enough room here, and then still need to minus 3. Okay, and we're nearly done. Expand it. It's going to be 3 lots of 16 over 9. I've squared the 4 over 3. You'd probably, you can obviously do this without a calculator. You know what, even I'm at this point going to just get the calculator out. Try and deal with mixed numbers as best as possible, but sometimes it's just easier. Okay, so -8 1/3. You could leave it, so you could leave it as a improper fraction, or you could leave it as a mixed number. -8 1/3, I think I prefer 25 over 3 actually, so I'm going to leave it like an improper fraction. And then the turning point is going to be, this is a happy quadratic again, it's going to be a minimum, it's going to be 4 over 3 minus 25 over 3. Let's just check my answer agrees with the one here. Okay, nice one. Try this one yourself. It's going to be another fractional one. It's arguably slightly less awkward because there's not 3s and 9s going on. Okay, take out the 4. This time it's going to be a half x. Complete the square. It's going to be a half of a half, which is a quarter. And I'm going to minus a quarter squared. It's absolutely fine if you can just figure that one out to just go straight away and write it down. You can use a calculator. I'm trying to do this. I know I cheated a little bit here. I'm trying to not use a calculator too much. Then I get, expand this out. I know it looks so much more complicated than the original quadratic, but it tells us useful things, and we're going to do a bit more on the use of it next lesson. So then it's going to become 4 times 1 over 16 is actually 1 over 4 again, so I'm going to be minusing a quarter and adding 5. And I could put this in my calculator, or actually I know that 5 is 20 over 4, so if I then minus a quarter, it's going to be minus 9. It's going to be 19 over 4. So there we have it. Let's just check. Nice one. Brilliant. So I got those right. I hope you, if you didn't, that you're happy with it. Okay, we're basically done. Like, that's it. It's just a case of continuing to practice now. I think, you know, if you want to, like, you can easily find more questions. I'm not actually going to set any today. You can find more questions where you practice this, but you practice 6 of them, and I'm going to get you to practice another 2. This one here is a sort of thing you'll be asked in an A-level paper. So it doesn't actually say complete the square. You have to understand that that is what it's talking about. And then have a go at B and C as well. So this one is slightly nicer because we're back to 5 actually going into the coefficient in front of x. So it's going to become x squared minus 4x plus 3. Complete the square on that. Sorry, I'm just trying to rub this bit out. There we go. X, right, bracket, x minus 2 squared minus 4. Which is then 5 x minus 2 squared minus 20. I do advise showing this level of working just in case you make a mistake. And we're nearly there. We just got to, you can see in the answer, P, Q, and R are integers, whole numbers. We can see we're going to get that. We don't actually need to state what they are. It's, you know, that's enough. We're done. B, find the coordinates of the minimum point. We know it's a happy quadratic, so this is the turning point. And it's going to be, you can just literally write, I know it's 2 marks, you'll get 1 mark for each coordinate. You can write down 2 and minus 17. Now C, I left this in, I nearly took it away. Haven't talked a lot about normals yet, but I think, you know, now is a good time to bring that in. If you weren't sure, fair enough. So when you have, we're looking at the minimum point. If you draw something like this, hold on, let me try that again. This is actually a tangent to the curve because it just glances off of it. If I move it up, it does anyway. The normal is then the line that is at right angles to that. So it's this one here. And it's none other than the line of symmetry in this particular case. Okay, you could get tangents and normals elsewhere on the quadratic and it wouldn't be the line of symmetry, but right at the bottom, the tangent is just going to be, actually it's probably worth talking about what the equation of tangent would be. Well, it's going to take the value of the y. So it's going to be y equals minus 17. This is the tangent. Whereas the normal is the line of symmetry, and it's going to be the value of x where we go through. So it's going to be x equals 2. In our case, it's the line of symmetry. We'll look more at normals, but hopefully you're happy with that. And you now know, if you didn't already, what the word normal means. It means you have your tangent, and then it's the perpendicular line from that. You might have seen it before with circles, because when we want to find the equation of a tangent to a circle, we first of all find the gradient. Sometimes people say the gradient of like the radius line, but technically it's the gradient of the normal, and then from that you can get the gradient of the tangent. Not going to talk about that anymore, but that's how you deal with it. You might have seen that before there. One more challenge for you. Okay, here goes. We've done it with 2 and 3 and -1 and 5 in the previous example. Can you take a general quadratic and write it in completed square form, and hence write down its turning point? This is a big challenge. Are you up for it? Give it a go. Pause the video, give it a go. Seriously, like, just follow the same method. If you need to, go back to the examples and see what we did, what we factorized out, how we dealt with it, because it is exactly the same process. And if you can do this, it means you can do it when you know what A is as a number and B and C. Okay, it might be a bit more actually, arguably this is easier than the example that I had with these two here. I don't know, you might disagree, but seriously, try it out. I'm going to go through it in about 5 seconds. Here goes. We are going to factorize the A out. And this time I've got to do B over A x. I like to write it as a fraction like that. Okay, that's exactly the same thing. Now I'm going to complete the square on the inside part. So it's going to become x plus, and then I've got to halve the B over A. When you do a half times B over A, you just times the tops times the bottoms, you're going to get B over 2A. And I'm squaring that. And now I need to minus B over 2A all squared. I'm going to take that a bit steady. And I'm going to plus C. Now I'm going to multiply it out. And I'm going to do A times this thing here squared, which, as we've done on indices, we know we just square each term separately. So it's going to become B squared over 4A squared. You might have got tripped up there. Look, it's B over 2A times B over 2A. So you just times the tops, times the bottoms, you'll get that. You can take a shortcut and just square each term separately. We're not adding anything or subtracting anything, so it's okay to do that. And then I'm still adding C. And we're basically there. It's going to become A x plus B over 2A all squared. Right, the A and the A squared partially cancel. So I'm going to do plus C minus B squared over 4A. And we can't simplify that anymore. You could maybe write this as a under a common denominator, but I think it's okay to leave it like that. So the turning point, and we don't know if it's going to be a maximum or minimum. If it's if A is greater than 0, then it's going to be a minimum because you get a smiley quadratic. And if A is less than 0, it's going to be a maximum because we'll have a sad quadratic. But in either case, the turning point is going to be minus B over 2A, C minus B squared over 4A. I mean, sometimes I see people when they've learned this formula, I wouldn't learn it. I don't know, just make sure you can complete the square. It is a nice result though. For any general quadratic, you can just substitute A, B, and C in, as long as A is not 0, and you'll get the turning point. Okay, brilliant. Well done if you got that. If not, then did it make sense? You know, you could maybe have another go at it now I've explained it. Make sure you are on point with your completing the square. Well done.